Hello, welcome everyone to another installment of daily LeetCode live streams where we have fun doing LeetCode question. Can you ever imagine a day where doing LeetCode would be fun? Well, that's what we're trying to do here. Trying to make it fun, trying to do questions, trying to hit our goals and get to that next level in our careers, or maybe just to grow a new skill set. That's what we're doing over here. If you like what you see, if you like LeetCode, if you like data structures, if you like algorithms, if you'd like if you like listening to someone do LeetCode problems sort of in a podcast style fashion, then you're in the right place. If you want to see more of this, make sure to subscribe to my YouTube channel or follow me on Twitch. I do these every single day, 5 p.m. Eastern on weekdays. On the weekends, I do shorter videos pretty much whenever I wake up. But if that's your sort of thing, make sure to stick around, listen in, and join in on the chat. If you have something to say, let me know in the chat. I'm more than happy to address any questions, comments, or concerns. So with that being said, let's go ahead and continue on from where we left off yesterday. We're going to go here to easy difficulty and algorithms. We're going to sort by acceptance. We're going to go all the way to page 3. And we're just going to continue going. Let me actually get my YouTube channel up just to make sure that the live stream is sounding good. All right, everything's sounding good on the headset here. Let me get the analytics up just in case. And let's see where we are today. So we ended up with flood fill yesterday. One of our normal users, or I guess regular users that comes up on here, Rashawn, helped us solve it, give us a nice concise solution. So very cool, very important question to understand. Great practice with depth first search. So let's go now into this one and let's hope it's a good question, which it looks like it's not, but you know, sometimes you get good ones and other times you get bad ones. All right, so given an array of points on the xy plane, points where point I equals xi and yi, return the area of the largest triangle that can be formed by any 3 different points. Answers within 10 to the negative 5 of the actual answer will be accepted. Woo! I just let out a really big yawn because it's the end of the workday here. It's been a pretty productive workday, and sometimes you just got to let out a good yawn. So let's see what we have here. 0, 0, 0, 1, 1, 0, 0, 2, and 2, 0. The largest area out of all 3 points. Let me think about this. It wants the largest area. Return the area of the largest triangle that can be formed by any of the 3 points. So given a set of points, we want to draw a triangle and we should make it so that that triangle is the largest that it can be. How is it that we find the area of a triangle again? It's like half of base times height. Oh, wow, yeah, half of base times height. Okay, cool. Been a long time since I've done that, so I'm glad that I still sort of remember it. Half of the base is 2 times the height, so that's 2, okay? Here we only have 3 points. All the given points are unique. I wonder if people don't like this question because it has more to do with like geometry and math than anything that might be useful in a programming style interview. I'm going to, like, what's the good thing about this stream? We have the choice to decide what it is that we want to work on and what we don't. This to me does not strike me as a question that's worth knowing for someone that maybe is preparing for an interview, a technical style interview. Perhaps this is geometry. I'm going to look at the related questions. We have array, math, and geometry. I'm not very concerned about doing this question, so I'd rather go to another one that might provide a better like to dislike ratio. So let's see maximum population here. All right, you're given a 2D integer array, logs, where each log, birth, death, indicates the birth and death years of the ith person. The population of some year X is the number of people alive during that year. The ith person is counted in year X's population if I is in the inclusive range birth to death minus 1. Note that the person is not counted in the year that they die. Return the earliest year with the maximum population. Okay, so let me see, 1993 and 1999. Where each logs of I indicates the birth and death years of the ith person. Okay, so this person lived from 1993 to 1999. this person from 2000 to 2010 happened in years 1960 and 1970. So is this just intervals like 1950 through 1961? But then you had someone that lived from 60 to 71, so that's also an interval. And then you have 1970 and 1981, that's a new interval. So it seems to me like we want the longest interval between any of these. So can we sort it by birth year? And then anytime we get to a year that's greater, so if the birth year is less, and it needs to be, person is not counted in the year that they die. So I think birth year needs to be strictly less than the death year of the previous date. Oh, right. As long as that's true, we increment 1. Now this one, 1960 to 1971. So this is 1970 to 1971. It's not 3. Because this person didn't live from 1950 to 19, okay. So I think this is a really good question for us to draw out. There's really no point in me trying to do this just off the cuff like I was gonna try and do now. Scala draw, our favorite tool here on LeetCode Live. And I wonder how we can normalize this. Well, let's just make it a standard line. And let's start drawing a little bit. Let's get ourselves some points. 1961, let's say. This is like 1960. Then we'll have 1971 over here. Or maybe that's 1970. We'll have 1971. And then something like 1981. Maybe these lines are not positioned very well. But let's see. Here we can have 50. Let me just copy all these so we can see exactly what it is that we're looking for. So that's 50. Let's make this 60. Let's make this 61. Let's make this 70. Let's make this 71. And let's make this 81. So let's get our line tool and let's give it a background. So we're going to go from 1950 to 1961. So we have here, that's way too big. And you know what? We should actually maybe use this. 1950 to 1961, that's 1. Then we have 1960 to 1971. So let's say over here. And then finally we have 1970 to 1981. So right here. So what is it that we're looking for actually, and why is it that in this range, let's see, because here, wow, I'm yawning a lot today. Just one of those days. So how many people lived within this range? Because it says maximum population is 2, and it happened in the years 1960 and 1971. Or 1960 and 1970. Because like I guess right here, you had, well, 2 people that lived, right? The one that was born here, and then here you also had 2 people that lived. Oh, I see. So it is true for both. Okay, I see. Earliest here with the maximum population, 2 and 2. Okay. So no, I think I was doing the algorithm correct. Both of them had 2, but the earlier year is 1960. So if anything, you have to find the one that is shared among them. So let's think about this. If that's the maximum, do we just take the birth year? 1960 and 1970. So you take the maximum with the birth year, and maybe that's the answer. 1993. What I'm thinking about doing, let's see if we can do this. Let's say const sorted logs equals to logs.sort. This will take log 1 and log 2. We'll do log 1 of 0 minus log 2 of 0. That way this will be sorted by that first number. And then what is that we want to do? We want to say for let I equals 1, I less than sorted logs dot length, I plus plus. I think here we should have some sort of literal. So max is equal to this, where max is population. Let's say population is 0, and year we'll also say is perhaps 0. So what we can do here is we can say if sorted logs of I of 0 is less than sorted logs, let me actually delete this, sorted logs of I minus 1, 0. Let's see. What is it that we want to compare every single time? We just want to add 1, and we'll always compare it to, let's see, if we find a new max and the year is the same. See, I don't want it to be the year. I just always want to count. So let's say here, okay, we count 1 and it's 1960. Okay. But I guess the years have to be the same. That's the part that I'm finding a little bit tricky here. I guess if I start at the ith position, if I start at 1 here, I'll do that comparison, right? It will be true, so now I can set the max to 1. Like the population here is, well, actually it should be 2. Oh, that's also weird that maybe I don't actually want to start in that second one there. I'm almost trying to solve this like I would maybe like an intervals problem, but perhaps that's not the best way to go about this. Maybe I can just consider every year on its own and say we have like this one person, like we can get to this one and say, okay, well that's one person, right? Because we're at someone now, and then we get to the next person and we say if they died before the previous person died. Okay. Is that the best way to go about it though? And then we get to the next one and we can say 1970 and 1971, but the year is not, we want to return the earliest one and this year is later, so we don't actually set it. But why would 1950 and it happened between the years 1960 and 1970? 1950, 1961, based on our drawing, let me see here. Maximum population year. Maximum population year. We have a range and we just want to see how many, like, each one of these ranges can fall into a bucket. And if, like if we look in here, we have the 1950 to 1961 bucket, which has 1. This one also falls into there. Then we have the 1960 to 1971 bucket, which has this one and this one. And then we have the 1970 to 1981 bucket, which has this one and this one. So it's like this one, this and this. This one has this one and this one. Wait, so is that 3? Well, no, because by the time this person's alive, this person's already dead. Because this one's not the same as this one. I might be overthinking this one, because it seems almost like a relatively straightforward intervals question. Birth, death, less than 2050. Oh, okay. Wait, where am I? Okay. Like this one's less than this one, so I can include both of them. This one's less than this one, so I can include both of them. But why would we stop? And I could say, okay, but what's the birth year? Tricky, tricky, tricky. Don't want to spend too much more time on it. Normally easy questions should go by a little bit faster at this stage, so note the person is not counted in the year that they die. Might go to another one. I think I'm going to be more aggressive in like skipping questions if I feel like there's any. Obviously, my plan is to get to like a lot of the struggling at the end. When we're like let's say we have like 50 questions left to do all the easy questions, then those streams are going to like have a lot of struggle. I want to really struggle on those last ones because we've already done a majority of the questions. But in the beginning, I'm looking for more quantity. So let's try another one of these. Element appearing more than 25% in a sorted array. Given an integer. So sorted is an extremely important keyword here, right? I just know it is because the first thing I think of when I see sorted is a binary search. So given an integer array sorted in non-decreasing order, there is exactly one integer in the array that occurs more than 25% of the time. Return that integer. So let's think about this. Because there might be, if it's more than 25% of the time, like, can we find a pattern? I guess this is just 0. This would be 0.5. A quarter of this is what, like, is it 0.75? Yeah, 0.75. 4 would be 1. So I'm just trying to find, like in this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have 10. So that's almost like two something, right? So how can we use, like there's got to be something special about the index where that number starts based on the fact that it's 25% in a sorted array. Because if it was 50% of the time, if it occurs more than 50%, and let's say the array is of size 10, then we should look in the, because more than 50% would be more than 5, right? So there's 6 of them. So that means it would have to start in the 4th one, which is almost like the halfway point minus 1. And that's because it's, so can we do the same thing here? If I do 10 divided by 0.25 minus 1, so what does that give me? What's math.floor of 10 minus 0.25? 10 divided by 0.25. But if we also did, oh, so should we just do, okay, so let's do this. That's 2 minus 1, but then that gives us 2, and that's not even where the 6 starts. So that's completely off. Occurs more than, so yeah, my thing was like, yeah, 50% I guess is, 50% is a little bit trickier. I mean, there's also one very easy way to do this, right? So we can do this calculation, and whatever number is greater than this to start off with, but the fact that it's sorted, there's got to be a better way. And look at the bounds too. The array is, I don't want to say it's like very large, right? The length that this can get to is 10 to the 4, which is not, I mean, I guess it's not crazy, but it is sorted, so we must use that to our advantage here. You guys might hear the ice cream truck. Given an integer array sorted in non-decreasing order, there is exactly one integer in the array that occurs more than 25% of the time. And if it's sorted, the array is sorted. How could a binary search here help us? Like if I go to the halfway point, right? What does that number tell me? It doesn't really tell me anything, right? Maybe binary search is not the answer here, but there might be something else. What if we just did like 2 pointers? If we're going to start from the front and another one start from the back. We have a 1 and a 10, a 2 and a 10, a 2. We also could do, let's see. Yeah, I mean, let's try the first way with using extra storage. And what do I mean by that? I mean doing something like this. So const frequency, and actually we can just do this all together in a single loop. So we can first take, let's see, more than 25%. I don't know, const percent equals math.floor of array.length times 0.25. And then we can say for const n of r, we'll also create a frequency object literal. Frequency of n equals frequency of n plus 1 or 1 if frequency of n is greater than percent, return n. So this should give us the answer. However, based on that keyword, I don't feel great in saying that this is the optimal answer. The array is sorted, and yet our solution has to traverse the entirety of the input array, which is why we're getting this question with a lower time complexity. Not something that we really want. $25.76. Ooh, I almost clicked solution, and I even clicked discussion, but we got out of there before anything happened. How can we optimize this? There's exactly one integer in the array that occurs more than 25% of the time. And it's sorted. If I use 2 pointers and I say, well, I have a 1 in the beginning, a 10 at the end, what does that really tell me? What is important about 25% of the time? It's like a quarter of the array. So a quarter of these numbers are going to be greater than, or there's going to be some amount of numbers that are greater than the quarter of the length of this array. And they're sorted in non-decreasing order. Anything special that we can do with that? Even if I use like a modified binary search, would that help me? Because what am I looking for? I mean, I'm looking for that one integer. If you do a search, what are the conditions of that? What can we say? I mean, well, actually, I wonder if for any number 2 and 2 and 1. No, because if we have an array of, yeah, no, that's completely out the window. I was thinking of some wild thing. Can we? Oh, wow. Okay, that's good. I'm glad that the related topics here barely give us any extra information other than array. More than 25% of the time. Is this, can we like, what if we move a pointer? It's in sorted order, sorted non-decreasing order. They're all increasing. One integer in the array that occurs more than 25% of the time. If I had like a set, that's just going to give me back unique numbers. I'll just get 1, 2, 6, 7, 10. That's not going to do anything. An object literal we can use to keep track. I don't think a sliding window here will help. Well, actually, would a sliding window here help? Could a sliding window here help? Or wait a second. We can just keep the length. We can keep a count of the numbers, and anytime we don't really need, we just need the current count of the number that we're on. So like, let's say we have a previous number, and let's say none of these. Okay, this can be 0. Okay, so let's make previous -1. Okay, check this out. Because this is just going to be a string of numbers, right? Because it's in sorted order. So if I say let previous equals -1, I can say, or let's also say let previous, and then let count equals 0. For const n of r, if n is not equal to previous, then what we can say is previous equals n, count equals 0. And now here, can we do count plus or equals 1? Let me just see how this comes up. So let's say we have this array and our count is 0, previous is -1. We're at n. So if n is not equal to previous, previous now equals to n, count equals 0, then we do count plus plus. Then we get to 2. It's not equal to previous, so previous equals 2, count equals 0, and then count plus or equals 1. We do this one. If n not equal to previous, it is. Count equals to 2. We go to 6. So I think anytime we increase this count, we can say if something like this, like if math.floor, or we can also just, let's just take the percent, right? Let's calculate this once, since that's going to help. If count is greater than percent, we return n. And I'm going to make all these lets sort of for consistency. Previous is -1, count is 0. Let's try this one out. 6 and 6. 6 and 1. Let's submit. Okay, look at this. Drastically better results. Man. Okay, it took me a while to get to this one. But something cool that I thought of was I started going through different algorithms, different data structures in my head. And when I got to sliding window, the thing that made it click for me was in the sliding window algorithm, I can just continue expanding my window as long as the numbers inside of them are the same. And then when I get to one that's not, I can take the length of the current window, which should have all the same number. And if I ever see that that length is greater than the percent, I can return that number. But then I thought, well, I don't really need to keep track of those pointers. I can just keep track of a single count. Since this is sorted, same numbers will always appear next to each other. I already have my percentage. I can even maybe get away by just, doing this. And I guess this is probably, well, I don't guess. This is probably a constant time operation. It's nothing that takes too long to do. So probably even just inlining it like this is fine. We still get a nice number here. So yeah, pretty happy about that. Count equals 0, else count plus or equals 1. That's very cool. Yeah, I'm glad that we were able to go through that and we saw the improvement here. So in this algorithm, right, we're having to keep track of the space, the frequency, which in this case is going to be n, right? Space-time complexity is n, even though the time is linear, is also n. Here, however, our time complexity is still n, but our space has been reduced to constant space complexity. And that really benefits us. So yeah, very nice question. Very nice question. I know I haven't updated my list in a while, and I definitely have to. So let me close this out, just make sure. Okay, sweet. Cool, let's get to another one. Find all numbers disappeared in an array. This one's a classic question. It took me forever to figure this one out, but since I already know how to do it, I want to take the time to explain it to everyone. I know sometimes I've said, oh, maybe this channel is not necessarily to teach you all how to do LeetCode, but because I have a good experience with this question, I have done it a couple of different times. I'm pretty happy with it. I feel good about it. So give me like 2 seconds. I'm going to step out literally for 10 seconds. I'll be right back and we'll get to find disappeared numbers. See you all in 1 second. All right, I'm back. Yeah, 2 things I wanted to do. I just wanted to open my curtain in my room so I can let some more light in. And I also wanted to put my desk on standing mode. And I'm afraid that probably the vibration and noise might cause a little bit too much feedback on the mic. That's why I want to go on be right back mode, I guess. I'll call it be right back mode. All right, so find disappeared numbers. As it is very clear here, this is a very popular question that I'm going to preemptively like because I have done it and I think it's phenomenal. So let's get right into it. Given an array nums of n integers where nums of I is in the range 1 through n, return an array of all the integers in the range 1 through n that do not appear in nums. Now, there's like a couple of key points here. I believe, let's see, the range, okay. Given an array nums of n integers where nums of I is in the range, already this is very important, in the range of 1 through n, return an array of all the integers in the range 1 through n that do not appear in nums. So because everything is from 1 through n, right, and not from 0 through n minus 1, for example, it means that we can do something particularly interesting. So let's take a look at this. Let's get this array and let's figure it out. We know that the numbers that are represented in here should be from 1 through n. Now, one thing that it doesn't mention is that they're unique numbers, because I do guess, let me see, is in the range, I guess by this you might assume that every single number has to be represented, right? So if we think of 1 through n, this is 0, 1, 2, 3, 4, 5, 6, 7. It's a length of 7, so we should have all numbers from 1 through 7. N integers, yeah, 1, 2, 3, 4, 5, 6, 7, 8. Okay, because I saw this 8 and I was like, what is that for? So imagine this array was like sorted, right? This would be 1, 2, 3, 4, 5, 6, 7, 8. Now let's just go through this together, right? Do we have a number 1? Yeah, we do have a number 1. Do we have a 2? We have a 2. Do we have a 3? We have a 3. We have a 4. Do we have a 5? We don't have a 5. Do we have a 6? We don't have a 6. But we do have a 7 and an 8. So what can we do? Because we have these numbers going from 1 through n, there's something very sort of important that we can do. Imagine all these numbers were in the right place. We can sort of start marking off, and I wish I had a better name for this pattern. I don't really think there is a name. It's just one of those things that, I guess the pattern is trying to use the input as a storage mechanism. Instead of having to create new storage, use the thing they gave you to store data that will help you come up with the answer. So you saw how we just said, do we have a 1? Okay, we do have a 1. It'd be nice if I knew, if there was a way for me to mark that information in here in such a way that I can go back in this array, loop through this and say, well, I already know that I have this number, or I don't have this number, so I need to add it to my result. So let's see if we can do something. Remember, 1 through n. So if I'm looking for a 1, right? Because this is all plus 1, I can go to like index 0, right? And say, okay, I know I have a 1, so I'm going to go to index 0. And I think even the better way of doing this is actually not to go to, don't actually use this here, use this here. So if I'm looking for a 4, I say I want to go to index 4 minus 1, and that's going to be index 3, right? So 0, 1, 2, 3, and I'm going to put a negative 7 here. Then I'm going to go to 3. I'm going to go to index 3 minus 1, which is 2. 0, 1, 2. I'm going to put a negative. I'm going to make that value negative. Then I'm going to go to 2, and I'm going to make sure that I'm taking the absolute value of each one of these numbers as I go along. That way I don't accidentally go to a negative or out of bounds index. So I'm going to take 2. 2 minus 1 is 1. I'm going to go to index 1, make that a negative. go to 7 minus 1, 6. So 0, 1, 2, 3, 4, 5, 6. Make that a negative 1. I'm going to go to 8. 8 minus 1, 7. Make that a negative 1. I'm going to go to 2. 2 minus 1, it's already negative. Don't do anything. Then I'm going to go to 3. 3 minus 1, 2. That's the one I just did, right? Now this is why we normalize it to that 0, or why we do 1. Because if this is a 1, but since we know it's 1 through n, we can do 1 minus 1, which is a valid index. If this wasn't 1 through n and we tried to do 0 minus 1, that's going to be negative 1. So we'd have to come up with a different way of doing it. But because this includes all numbers in this range, we can say let's go to index 1 minus 0, 1 minus 1, which is 0, and make that a negative. Now there's a very interesting thing that happens here. Do you notice anything with the array that I drew up here earlier? Let me make these numbers a little bit more clear, and let me see if I can try to align them a little bit better. But the only two numbers from this array that do not have a negative are 5 and 6. And check what our answer is, 5 and 6. So it's a two-step process. First thing we're going to do, we're going to mark all the positions that we know we have with a negative number. Then we're going to go back and loop through this modified array, and at any index that we have a positive number, that means we never got to it. So assuming we have this sorted array here, we'll just add 1 to the current index we're at, 5 and 6, and that'll give us the output, 5 and 6. So let's go ahead and do that. I hope that makes a little bit of sense. I know it's not something that I would honestly expect someone to get the first time around. This is definitely something that you've had to have seen, I think. It's a very clever trick. Let's go ahead and do it. So for let I equals 0, I less than nums dot length I plus plus. Now the first thing we want to do is we want to get the index. So say the index is math.abs, remember, of nums of I minus 1, right? And actually we want to do the minus 1 afterwards. So const index is math.abs of nums of I, so 4 minus 1, 3. We want to check if this is already a negative number, and we can do that very easily. If math.sign of nums at index, okay, equals 1, then all we need to do is say nums of index equals negative nums of index. Okay, so let's look at a couple different things, because there's some nice sort of JavaScript, not tricks really, I would say, but some nice JavaScript things we did here. So we took the absolute value of this number, that way we don't ever get into an out of bounds situation. So we say math of abs of 4, which is 4 minus 1, that'll give us the index 3, so 0, 1, 2, 3. By using math.sign will return a 1 if it's a positive number, or a negative 1 if it's a negative number. So we only want to do things with indices that have positive values. So if math.sign of nums.index is equal to 1, then we'll just go ahead and flip the value. Nums of index equals negative nums of index, and we'll end up with this. Now we can start formulating our result. For let I equals 0, I less than nums.length, I plus plus. Here we can say the same thing. If math.sign of nums of I, again, is positive, that means we never got to it, because this whole process was making things negative. If we're still at a positive number, then what do? We say result.push I plus 1. And why are we doing I plus 1? Because at the end of the day, we're starting at 0. We still need to start at 0 so we can go through everything in the array, but we add 1 because it's going to be the 5th and 6th index, not the 6th and 7th index. That's something that we have to normalize. The range is 1 through n, but our indices remain from 0 through n minus 1. And at the end, we can return result. Let me remove these. Let's run this. Let's see what we get. So 5 and 6 for our first test case, and for our second one, 2. Let's submit it. And we have 68.16 for time complexity and 86.77 for space complexity. The nice thing about this one is for time complexity, we iterate through nums n plus n times, which normalizes to just O of n. And our space complexity, the best part is it's constant space, because we actually get to use the input that we got, nums. Now, some people might consider, there's a lot of times where people say, well, the output isn't considered extra space. Yeah, maybe so, maybe no. I suppose in the worst case, is there any way that we can get every single thing, like any number? There's going to be some amount of numbers that are present and some that aren't. So it's going to be some amount. I don't know how to write that in space complexity, but O of some amount of numbers that are missing. That's how large this result array will be. So I really hope that was helpful. Rewatch the video if that didn't make sense. But really the big takeaway here is, for many questions, the pattern is, or the optimal thing to do is to, instead of create a new data store or another data structure, use the thing that they gave you, modify the input. And if you can figure out a way to cleverly manipulate indices or values, you can use that to your advantage. It's like, for example, marking items in a graph as -1 after having already visited them, and using that to know that you visited some cell instead of creating like a set. So another very clever thing that you can do. So some nice questions we got to there. Let's get to our next one here. Slowest key. We have a boatload of text here. So let's see what we can do. A newly designed keypad was tested, where a tester pressed a sequence of n keys one at a time. You're given a string keys pressed of length n, where keys pressed I was the ith key pressed in the testing sequence, and a sorted list release times where release times I was the time the ith key was released. Both arrays are 0 indexed. The 0th key was pressed at the time 0, and every subsequent key was pressed at the exact time the previous key was released. The tester wants to know the key of the key press that had the longest duration. The ith key press had a duration of release times I minus release times I minus 1, and the 0th key press had a duration of release times 0. So note that the same key could have been pressed multiple times during the test, and these multiple presses of the same key may not have had the same duration. A lot of text to try and understand. The key presses were as follows. Key press for C had a duration of 9. Key press for B had a duration of 29 minus 9, 20. Okay. Key press for C had a duration of 49 minus 29. Key press for D had a duration of 50 minus 49. The longest of these was the key press for B and the second key press for C, both with duration 20. C is lexicographically larger than B, so the answer is C. So it seems to me, let me see, key press C had a duration of 9, pressed at time 0 and released at time 9, and 29 minus 9, 49 minus 9. Okay, so it looks like to me, let's think about this. I think here we can keep track of, let's see, what if I said const slowest, where we had a duration of 0, and we also had the key. Maybe the key initially will be keys pressed at 0. Okay, so what I want to do, right, we're going to start with this. We can say that like let previous equals 0. So I can calculate this minus this. If I see that 9 minus previous is larger than the slowest duration, and let's see, does it have to be and? Because I'm thinking, do I ever want to, yeah, if I see that it's greater than the current or and greater than or equal to the ordering of keys pressed, then I'll update that. So let's see, I think we can figure this out like this. Let previous equals 0. We'll do for const, and maybe we want to do, let's actually do for let I equals 0, I less than release times dot length I plus plus const duration equals, we're going to do release times, and I guess we just want the absolute value, right? Because some, is it going to be an increasing order? Exact time, tester wants to know duration. Is everything in duration always larger? Let's assume that's the case. So duration is release times of I minus previous. So now if duration is greater than slowed duration, so if we have something new, only if it's strictly, I guess it can be, let's see. I guess they can each have the same duration. If duration is greater than or equal to slowed duration, and now this is where we need to see which one's larger, because I don't think, let me see something. Is D greater than A? Is that always the case though? Z greater than B? Can we just do a simple calculation like that? If duration is greater than slowed duration and, let's see, keys pressed of I is greater than or equal to duration or slowed dot key, and we'll say slowed dot duration equals duration, and slowed dot key equals keys pressed of I. And then at the end, we'll say that the previous equals this new duration. So then when we get to the next one, we can do 29 minus 9, or actually previous should equal release times of I. So duration equals release times of I minus previous. And then at the end, we should just be able to return slowed dot key. Let's see if this works. We have C and C. And we have this large string, spuda. Oh, ran it too quickly. C and U. Okay, we did A. Wait, output A. Output U. Okay, interesting. So let's see, and that's because the longest of these was the key press for A with duration 16. So let's think about this. The key presses were as follows. We had 12. Okay. Consideration is release times of I, 12 minus previous, so that's 12. If duration is great, oh, so it only needs to be, okay, let's think about this. Because here we have S, and we set this equal to what? Keys pressed of 0. If keys pressed of I is greater than or equal to slowed dot key, slow dot duration is, then we get to U, but then we get to A. So it has a greater duration. So only if there's a conflicting one. So anytime, let's see, I guess we just pick the larger of the two. We always do it by duration, and then we always pick the larger of the two keys. Can we do that? So if duration is greater than or equal to slow duration, perhaps we don't need that second one. Slow dot duration is duration, and slow dot key should be equal to what? Because now I'm saying the greater of the two. What was the previous one? If it's greater than or equal to slowed duration, only if they have the same. I see. So maybe here, if it's greater than or equal to, we can say if duration equals slowed duration, slowed duration, if duration equals slowed duration, if they're the same, then the key, maybe here the key should be the larger of the two. Either the thing that's currently either keys pressed or, and how do we, if I do like math.max, is that, that's very strange to do that with characters, but that's not going to work. The larger of the two. So we can say slowed dot key is if keys pressed of I is greater than slowed dot key, keys pressed of I, else slowed dot key. And the duration will always equal the duration. What is this? What does this do? C and S. I still had C and A, so there's something I'm missing here. If the duration is greater, but then we also get here, right? Else, maybe here else slow.key should just equal keys pressed of I. Slow duration is duration. Let's try this one. I'm getting into that territory. Okay, C and A. That's okay. I was about to say I'm getting into that territory where I'm just writing things down, and we could be getting into like, is it not very clean code territory? But we got it right, so that's nice. So let me just try and clean this up a little bit. I mean, this is very nitpicky stuff, but you know, having things on the same line if we can. This whole thing right here is a little bit all over the place. So let's see what we can do. So slow.key. Let's see if duration is greater than or equal to slow duration. Let's see if it's greater, we'll just do slow.key equals keys.press. Else if it's equal, we can do that one, but the duration will always be the same. Can we just always take, actually, can we just always do this? Does it really even matter? Because well, I'm sort of risking my acceptance rate here. Yeah, okay. So it does have to be two separate cases. Let's see what the solutions say for this. Using a map, find the duration of all the key presses. Find the key with the longest duration. Build the map duration map to store the key press duration of each key. This is a lot of stuff happening here. Wow. Okay. Fixed size array. Oh, wait a second. Is this because constant extra space? Also keep track of the slowest key found so far. In this way, the solution can be implemented in a single iteration without the need for an additional data structure. Each iteration requires only constant time. Although here well, does the space complexity here change? No, the constants, this is still slowest key. Well, I guess we could, yeah, I just put this all into an object, but this is still constant space and linear time. So I'm quite happy with the solution here. Even though I looked at the solution here, I feel like this is the actual way. Into duration, if current duration is greater than longest press or current duration equals longest press and keys pressed, update the slowest key and the longest press duration. So it seems very similar to this one, so I feel pretty good about that. Let me see, we're about 4 minutes left on the stream, and I see right now it's a little bit unfortunate that most of my viewership is coming now at the end of my stream, but for everyone that's watching, I really appreciate you all being here. I really hope that these streams are fun for you. I'm trying to make this like a podcast for LeetCode. Does that even exist? Maybe it does, maybe it doesn't. The main thing being is I'm trying to be relatable. Some days I have really good days. You may have seen some streams sometimes where I get to like 2 questions, and the second question I'm just feeling really bad. So it's just to show that people that are on the LeetCode grind have great days and bad days. And that's just the way it goes. All right, given the root of a binary search tree and a target number k, return true if there exist 2 elements in the BST such that their sum is equal to the given target. So I think I have done this one before. So this definitely requires a draw, and I'm not even sure, should I try and do this one now? Because it's going to require more time. And let me see what this one does here. Given a binary array nums and an integer k, return true if all ones are at least k places away from each other. Otherwise, return false. Okay, so 1, 0, 1, 2. Each of the ones are at least 2 places away. Okay, I see. So we always want to get to, these are 2 because there's 2 zeros. So we want to count the amount of, zeros in between each one, and every time we get to a 1, the amount of zeros should be less than or equal to 2. So we can say let 0 count equals 0 for const n of nums. Let's see, if n is equal to 0, we'll say 0 count plus plus, else, let's see, if 0 count greater than k, return false, else 0 count equals 0. And then here we return true. Does that seem reasonable? Let me run this. Or did I just do that way too fast? Okay, false and true. Probably completely missed something here. So we start with the 0 count of 1. If n is equal to 0, else if 0 count is greater than k, which is not, 0 count equals 0, okay. Come to the next one, that's 1. 0 count plus plus 2. 0 count plus plus 3. Then we come over here. If 0 count, oh wait, as long as it's, so it needs to be if it's less than k, return false. Oh, you're kidding me. The second one and third one are only 1 away from each other. Okay, but here we have, oh, wait a second. They want me to also do return true if all ones are at least k places away from each other. But does it really matter? Does it really matter these? Because if every distance in between is fine, I think that's okay. The second one and third one are only 1 apart from each other. If 0 count is less than k, return false. 1 and 2. Zero count and then return true. So why am I getting false here? Because this should be, if n is equal to 0, which it's not, this is going to be a 1. Then we come to here, 0 count plus plus, that's 1. Come to here, 0 count plus plus, that's 2. Come to here, 0 count plus plus, that's 3. We come to here, n is not equal to 0. So is 3 less than k? No. So now we set 0 count to 0. We come over here, 0 count plus plus, that's 1. 0 count plus plus, that's 2. Come over here. Is 2 less than 2? No. It's equal to 2. So 0 count is equal to 0. And then we finish and we return true. There's got to be something. It's almost, else if 0 count is less than k, return false. Each of the ones are at least 2 places away from each other. So if it's ever less than k, we return false. Let's do something here. Very, very concerned here. Well, okay, really for the first one? I guess that's just as important, right? Obviously. So do we just need to get, now, do we always, I'm guessing we don't always have a 1 in the beginning. Yeah, so we need to find, let's see. We got to a 1, but now the thing is, so we need to keep track of pairs of 1s. Like first one and second one, and compare the distance. So I think maybe we should do that instead. Yeah, we find the first one, then we find the second one, we compare the distance, and then we keep going that way. So let me see, let current equals 0, let runner equals 0. So let's say while current is less than nums.length, and runner is less than nums.length. Let's see. So while nums of current not equal to 1, current plus plus. And then we'll set runner equal to current, while nums of runner is not equal to 1, we'll say runner plus plus. And then here we can say the distance, right? So 0, 1, 2, 3, 3 minus 1 is 2. So if runner minus current is less than k, then we return false. Else now we set current equals to runner. And we now restart the whole thing. And just for good measure, we should also say while current is less than nums.length. And here we'll also say while runner is less than nums.length, return true. Let's try this. While it's not equal to 1, current plus plus, runner equals. I am really confused here. Is it because, and I guess we're just setting this one, we probably want to set runner equals to current plus 1, and then current equals runner plus 1. That's a fault. Wow. This is like the first time in my head. But this is what happens, right? This always happens to me. I start doing this, I start coding, then I get to a point like this. Okay, so current is 0, runner is 0. While current is less than nums.length and nums of current is not equal to 1, which it is, current plus plus. Okay, now runner equals current plus 1. While runner is less than nums.length and nums runner is not equal to 1, we continue, it's equal to 1. Okay. If runner minus current, so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, minus 1 is 3. 3 is not less than k, so we don't return false. Then we say current equals runner plus 1. Or actually, in this case, it probably should be runner. Current equals runner. And should we also set runner equals to current plus 1 again here? Do we just start at the next one? While current is less than nums.length. Oh no, that's fine, because we'll set current to runner, and then we'll say while current is, so this won't even go up, runner equals current plus 1, and we'll keep going all the way. And of course, it's complaining about my little drawing up there. This is incredible. Because here, so runner equals current plus 1, while runner is less than nums.length and nums of runner is not equal to 1, if current minus runner, if runner minus current is less than k, so 0, 1, 2, 3, 4, 5, 6, 7. 7 minus 4 is 3. That's not less than k. Current is equal to runner. Okay, while current, that's fine. Runner equals. Okay, so runner equals current plus 1. And now we get to a case where this one's out of bounds. So while runner, which is just a number, is, well, no, while runner is less than nums.length, okay, that breaks. If runner is, I guess, do we have to say the same thing again here? Do we ever, if, so if current is greater than nums.length or runner is greater than nums.length, we break? Give me a true. This has to be like the most confusing question I've done. because I get to this piece here. If current is greater than nums out length, and of course, here's another small flaw. Okay, I deemed this question the best example of trying to code faster than you can, like, how do I say this? I jumped right into this. This is an example of me just jumping into code, trying to just figure it out without even taking a second to think. Because now we're getting both of these incorrect. So I think for the sake of the stream and me not just writing some crazy looking code here, not really even taking a second to think about this, maybe we should probably wrap it up here. Probably would have been better to go over this, which we'll do tomorrow, because I think this definitely warrants a nice drawing on Excalibur. And there's a very nice way to do this while taking advantage of the binary search tree. Well, definitely there is, and I'm pretty sure I've done this question before, but we can go ahead and try our shot again. So with that being said, thank you all so much. Thank you to all who watched the stream today. Really appreciate you all being here. Hopefully you gained something from this. Maybe you just had a nice hour to hang out, listen to someone talk about random LeetCode things, and just have fun with it. Till next time, till tomorrow. See you all back here again. Oh, Marius World, thank you so much for following on Twitch. Really appreciate it. Always very happy to see new people following me. I hope that you continue. Hope I continue to see you around. Hope you continue being part of the chat and everything. Until next time, tomorrow at 5 p.m. Eastern time, find me on YouTube, find me on Twitch. If you like me, subscribe to me on YouTube, ring that notification bell, follow me on Twitch like Marius World did, and